I think you know y is equal to mx plus c. What is m? What is c? Fine. So, in physics or in motion, we use the formula. In motion, we use the formula v is equal to u plus at, right? Under which condition we can apply this formula? I think you are all aware about it. Under which condition we can apply this formula? When a body is undergoing acceleration. Not only that, rather more specifically when the body is undergoing constant acceleration, right? When a body will be moving under constant acceleration, then we can apply this formula to express the motion of a body, right? I hope we have discussed this term several times. So now if I ask you to compare y is equal to mx plus c with v is equal to u plus at. Now if I ask you to compare y is equal to mx plus c with v is equal to u plus at, then what will be your comment? What will be your statement regarding the understanding about v is equal to u plus at in the form of straight line? In the form of straight line, if I am saying that we can compare v is equal to u plus at, isn't it? We can compare v is equal to u plus at with the general straight line equation, that is y is equal to mx plus c. So we can definitely learn something specific, and that we can understand by comparing these two equations. When I draw y is equal to mx plus c, then if this is a line cutting x-axis at A and y-axis at B, if I am drawing the line y is equal to mx plus c, if this is the line, this line is given by, if this line is given by y is equal to mx plus c, where we know that where m is equal to slope of the line. Do you remember this thing? We have done it in coordinate geometry discussion, in straight line discussion in mathematics. Yes or no? If m equal to slope of the line, then when we draw a line on xy plane, then slope is numerically decided by using this geometrical angle theta, which is the angle between the line and the positive direction of x-axis. Tell me yes or no. Where m equals to, given by m, value of m, slope of the line is known by the numerical value of tan theta, where theta is equal to angle between the line and positive direction of x-axis. Between positive direction of x-axis and the line, the geometrical angle whatever we get, using the tan theta value of that particular angle, we write down the slope of the line. Yes or no? Am I correct? Are you able to understand me? Using the horizontal and vertical line, if I take the term velocity appearing, that is meter per second on y-axis, and the time which is in second, taken on x-axis, right? And if I draw a line, in a same way, suppose exactly parallel to AB, if I draw a similar line like AB, cutting x-axis and y-axis, this time x-axis is representing the time t in second and y-axis is representing the term v, that is velocity. Then again, taking the angle between the line and the positive x direction, the theta, if I use the slope of AB, MAB, that can again be written as tan theta. So now see here the graph was plotted x versus y or y versus x, you can say y versus x. This graph is y versus x and this graph is v versus t. So the slope is decided by the coefficient of x-axis variable. In y is equal to mx, the slope is the value, the slope of the line is decided by the numerical value appearing as the coefficient of x. M is appearing as the coefficient of x. When I am writing the graph is plotted velocity versus time, so the parameter which is taken along x-axis, the parameter is taken is time. So the term which is appearing as the multiplying factor, coefficient of t, that must be representing the slope of this velocity time graph. Are you getting me? Because when we are plotting y versus x, the power of y is 1, the power of x is 1. Similarly, when we are plotting the graph of v versus t, there also power of v is 1 and power of term t is 1. So both are absolutely comparable. So x-axis parameter is time. So the term which is multiplied with time must be representing slope. So that means here I can say slope of the line drawn on VT plane, slope of the line drawn on VT plane must be representing the acceleration of the particle. Are you getting me or not? If I am writing the slope of the line that I have drawn on velocity versus time graph on VT plane, then the theta, what we are getting in geometry between the line drawn and the positive direction of x-axis parameter, which is time t in second. So the value of tan theta, which will be the slope of the line, must represent the term called acceleration.